everyone and welcome to the next video. Today we are going to learn a very important type. What if in integration we have numerator upon a denominator? That means fraction upon a fraction. So how to solve that? We will use partial fraction. Now the first and the foremost thing which I want you to remember is for using partial fraction, the degree of the numerator has to be less than degree of denominator. This is the first thing which you have to remember, rule less than. Okay, so how will you do it? First of all, I want you to have a look at the factorization form which is given, partial fraction forms. If a question is linear upon, there are two linear factors upon the quadratic factor which have two separate factors, then the partial fraction will be a upon the first factor plus b upon the second factor, where obviously a and b does not match. If if the question is in the form of a linear fraction, linear this thing divided by a whole square polynomial, then the partial fraction will be a upon the linear plus b upon the whole square of the denominator which is present. So third, if there are three linear factors, this is just symmetrical to the first one. So 3 hai, so a upon the first factor, b upon the second factor, c upon the third factor. Again, the order doesn't matter. Again, 4 is little bit similar. Whole square hai, तो होल स्क्वायर में a अपॉन लीनियर फैक्टर भी आएगा, b अपॉन द होल स्क्वायर फैक्टर भी आएगा, और अगर कोई थर्ड फैक्टर है तो c अपॉन द लीनियर फैक्टर भी आएगा. Now, fifth point. Suppose we have a quadratic polynomial. This was again quadratic upon cubic. So you can see in everywhere the degree of numerator is lesser than the denominator. So again, quadratic upon cubic. Again, cubic mein there are two forms. One is x minus a, which is a linear factor, and the other one is a quadratic factor which cannot be factorized. Cannot be factorized means beta iska middle term splitting nahi ho sakta, yani ki ye ऐसे में स्प्लिट नहीं हो सकता. सो इस केस में पार्शियल फ्रैक्शन फॉर्म क्या बनेगा? a अपॉन द फर्स्ट फैक्टर प्लस लीनियर bx प्लस c अपॉन द quadratic factor which cannot be split. So this is what you have to convert. So first is, I will tell you, show you in the step is, the most important thing which I want you to remember, that the degree of numerator has to be lesser than denominator, then and only then you can use partial fraction form of integration. Let's move on to our exercise. Okay, first let's go for the steps. Step number 1. Forget the integration sign. You don't have to take the integration sign and convert the question into the partial fraction from the table given above. The table which I've just explained, just convert the identify which the question belongs to which partial type, and then convert it into the respective partial fraction form. After that, second, find the value of a and b using hit and trial method. Now here also I want you to highlight that there are many ways to find a and b. I don't want you to find the value of a and b using equating method. It is a very lengthy process. There will be a lot of time wastage. I will show you how to save time. But I want you to use hit and trial method. I'll explain you this hit and trial method while doing a question. Now, after getting the value of a and b, children, what I want you to do is now put the value of a and b in the first step, yani ki the partial fraction which we have taken out, put the value of a and b, and now you integrate. And now you integrate using your previous type. Either type 4 can be used, or maybe substitution can be used. So there are many ways to do it. Integration, Now, again, a very important note. Once again, partial fraction can only be applied if degree of numerator is less than, please forget the spellings, it is THAN, less than that of the denominator. Okay, so this is where you will apply partial fraction. Let's see. When we talk about exercise 7.5, let's talk about the first question, children. Integration of x upon x plus 1 into x plus 2 dx. I want you to integrate this. Again, linear upon quadratic. So x upon x plus 1, x plus 2, forget the integration sign, we are doing the first step. Check the table where partial fraction form are given. Since there are two linear factors with 1 degree, so we will have this. And now, when you will take LCM, children, on the right side, you know that A will get multiplied by x plus 2 and B will get multiplied by x plus 1, right? So denominator, this will always get cancelled. So here you will come to know. Always it should get, denominator should always, simplify, yeah, cancel each other. So now there are, see, here is where I want you to highlight a step. There are many books or maybe many, there are many students who do this question by this method. They open the bracket and then they take, equate the x terms and the constant terms. So equating x and coefficient of x, I mean, coefficient of x and constant terms. So we get a plus b is equal to 1 since x has one coefficient, and 2a plus b equals to 0 since on the left side we have no constant at all. So this is how they calculate the value of a and b by, now subtracting. This gets cancelled. This is minus a equals to 1. So a is equal to minus 1. You put the value of a as minus 1, so you will get b as 2. This is one way to find. Now let me show you the easier way. Or to get the value of a and b, children, I will just directly use, this was my, after taking LCM, this was left. Just I will put x as minus 2. So I know that a becomes 0. So minus 2 is equal to a minus 2 plus 2 plus b minus 2 plus 1. So this becomes 0. So b is equal to 2. Similarly, if I put x is equal to minus 1, children, x is equal to minus 1, b becomes 0. So I get a as minus 1. So you only tell me whether this method, 1, 2, 3, 4, 5, 5 steps, this method is more time saving or this method. So this method where we assume the value of x by checking out the factors is known as hit and trial method. So I will recommend that in your questions while solving while solving integration using partial fraction, I want you to do hit and trial method, not equating the coefficient method. So this is one time saving technique which I've told you. Okay, once we have got the value of a and b, now check what happens. Once we have got the value of a and b, I am erasing the method which I don't want you to do. Once we get the value of a and b, now check what has to be done. You just need to put the value of a and b in the partial fraction form. That is integration of a minus 1 x plus 1 dx plus integration of b twice of x plus 2 dx. So minus 1 goes out. This is log x plus 1 mod plus 2 goes out, log x plus 2 plus c. Again, you can simplify. Whenever logs are there, we can combine the term. X plus 2 is positive and 2 is up in front of this. You remember log x to the power n can also be written as n log x, and when there is a positive sign it comes in the numerator and minus means it comes in the denominator upon x plus 1 plus c. So this is the final answer. This is a way to do question using fraction upon fraction where degree of numerator, I am repeating again, degree of numerator is lesser than that of denominator. Let's do few more questions. Now have a look here, children. We can do partial fraction here. We can split this question into x minus 3, x plus 3, and then again apply the same partial fraction, a upon the first factor, b upon the second factor. Same way, this third question can also be done, a upon the first factor, b upon the second factor, c upon the third factor. Similarly, this can also be done, a upon the first factor, b upon the second factor, c upon the third factor. This you can split using, middle term splitting. 2k factors taki 3i, so 2x and 1x. And again, you will get two factors, again a upon the first factor, b upon the second factor. Have a look here, children. Here is the mistake. In this question, you cannot write this as 1 minus x square upon x into, just because it has two factors. You can't say that 1 minus x square upon x into 1 minus 2x will be a upon the first factor plus b upon the second factor. This is a wrong method. Why? Again, check the degree, children. Degree of numerator is equal to degree of denominator. So that is why partial fraction can't be applied. So we will do this question in the next video. So again, let's talk about question number 7. Okay, I wanted to do question number 7 for you people. Why? Because there is a x upon x square plus 1 x minus 1 dx. So x upon x square plus 1. One is a linear factor, children. The other one is a quadratic factor. But the quadratic factor is not factorizable. मतलब x square plus 1 को हम simplify नहीं कर सकते, ये split नहीं हो सकता. तो अगर कोई split नहीं हो सकता तो उसके ऊपर again आप partial fraction का table देख सकते हो, form 5, उसमें bx plus c आता है. Again short method हम करेंगे, x square plus 1 x minus 1 a into LCM ले रहे हैं तो x square plus 1 इधर आ जाएगा, plus bx plus c into x minus 1 upon x minus 1 into x square plus 1. Again, this and this gets cancelled. So question is x is equal to a into x square plus 1 plus bx plus c into x minus 1, children. Now let's see. Hit and trial कैसे काम करेगा इसमें. Put x is equal to 1. पहला चीज तो मुझे साफ दिख गया. अगर मैं x को 1 पुट करूंगी, ये सारा कट जाएगा. 0 into anything is 0. तो हमारी वैल्यू आ जाएगी 1 is equal to 2a, यानी कि a is equal to half. अब मैं पुट कर रही हूँ x को 0. अगर मैं x को 0 पुट करूंगी बेटा, तो 0 इक्वल्स टू a, यहाँ पे 0 into 1 1 रहा, प्लस b जो है b into x था तो b into 0 0 हो गया, प्लस c into minus 1. So यानी कि मेरे पास आ गया a is equal to c. So I got the value of c also as half, right? Now we got a, we got c. Now we have to get b. अब b मेरा कभी भी c और कोई और a कभी 0 नहीं आ सकता, राइट? तो हम 0 ऑलरेडी पुट कर चुके हैं, 1 ऑलरेडी पुट कर चुके हैं, तो एक छोटी वैल्यू और पुट कर लेते हैं. पुट x इज इक्वल टू -1. 0 और 1 के आसपास की छोटी वैल्यू जो कि सिंपल हो तो वो -1 होती है, तो -1 पुट करते हैं. तो -1 इज इक्वल टू -1 का होल स्क्वायर a इंटू -1 का होल स्क्वायर प्लस 1, यानी कि a इंटू 2 प्लस माइनस b, x की जगह प्लस c, -1 into -1, that is -2. Can we take 2 common and take it that side? So it will be a minus of minus plus a plus b minus c, right children? So we have to calculate b. So minus half minus a plus c is equal to b. So let's put the value. Let's put the value. Minus half, a is minus half, a is half, and c is also half. So b has come out to be minus half. So we got this. Now let's put it back in this. So integration of a x minus 1 dx plus integration of b plus c. Now again, half integration of 1 upon x minus 1 is direct log. Now if you want to do here x upon x square plus 1, check here children, this can be solved using सब्सटीट्यूशन मेथड, मतलब टाइप 2, आप एक्स स्क्वायर प्लस 1 को टी पुट कर दो, ऊपर डी टी आ जाएगा. सिमिलरली 1 अपॉन एक्स स्क्वायर प्लस 1 डायरेक्ट फॉर्मूला लग जाएगा टाइप 4 का, या डायरेक्ट वैसे भी tan इनवर्स x का फॉर्मूला आपको दिख ही रहा होगा. तो दिस इज हाउ यू विल सॉल्व. ओके, now question number 9 also. First try and factorize. We can factorize. x square common, अंदर x minus 1 बचेगा, यहाँ minus 1 common, x minus 1 बचेगा. Again you can take it whole common. So here the factors will be x minus 1 whole common, x square minus 1. So x square minus 1 भी factorize हो सकता है बेटा, तो उसको भी याद रखिएगा. x minus 1 into x minus 1 यानी कि x minus 1 का whole square. So x plus 1. अब इसका पार्शियल फ्रैक्शन फॉर्म क्या बनेगा? a अपॉन x plus 1 प्लस b अपॉन x minus 1 प्लस c अपॉन x minus 1 का होल स्क्वायर. तो जब भी होल स्क्वायर की टर्म होती है तो दो फैक्टर्स में डिवाइड हो जाती है, b अपॉन उसका लीनियर प्लस c अपॉन उसका होल स्क्वायर. सो दिस यू हैव टू रिमेंबर. अगेन क्वेश्चन नंबर 10 में अगेन एक्स स्क्वायर माइनस 1 स्प्लिट होके x माइनस 1 इंटू एक्स प्लस 1 हो जाएगा, और ये फैक्टर एज इट इज. तो a अपॉन फर्स्ट फैक्टर, b अपॉन सेकंड फैक्टर, c अपॉन थर्ड फैक्टर. अगेन इसमें भी ये स्प्लिट हो जाएगा x माइनस 2 इंटू एक्स प्लस 2, अगेन a अपॉन फर्स्ट, b अपॉन this and c upon this. Now question number 12, again you have to remember, in question number 12 there will, you cannot use partial fraction, can't use partial fraction. So first step is just एक बार क्वेश्चन को देखो और उसकी डिग्री देखो. अगर न्यूमरेटर की डिग्री छोटी है तो ही पार्शियल फ्रैक्शन लगेगा, अदरवाइज नहीं लगेगा. तो क्वेश्चन नंबर 6 में और क्वेश्चन नंबर 12 में पार्शियल फ्रैक्शन नहीं लग सकता. ओके, this is again partial fraction, a upon the first factor plus bx plus c upon the second factor, because ये split नहीं हो सकता. This is again a upon the first factor यानी कि x plus 2 plus b upon x plus 2 का whole square. Okay, तो till question number 14, even you can do question number 17 also. अगर मैं sin x को t put कर दूँ तो cos x dx equal to dt हो जाता है, right? तो ये मेरा question reduce हो जाएगा dt upon 1 minus t into 2 minus t. Again partial fraction, a upon first factor, b upon second factor. So we have, there are many questions which are left in the exercise. We will continue in the next video in the next forms. So this is all about partial fraction. Hope it is clear. We'll continue the exercise. Thank you children. Thanks for watching.